for General Mathematics, Module 4, Exponential Functions. This virtual class will be recorded so that the people who are not here will be able to watch the virtual class recording in the future, inshallah. So just a little bit of a review from the last module, which is the one-to-one function and inverse function. So one-to-one function is a function that has an x element and one y element as well, and it cannot have any other elements aside from that. Also, if a function is a one-to-one function, then it is reversible. And how to inverse the one-to-one function? There are three simple steps. So you have to first, the function of x shall be put into a y and then interchange the y and the x variables. And then the last step will be to just solve for y in terms of x. So as simple as that. And by the way, one of the real life representation of the one-to-one function is its application on cryptology or encryption and decryption, which we actually use in our daily lives whenever we log into social media accounts or any other accounts for that matter. We are using passwords, and that uses encryption and decryption technology. So today we are going to talk about the exponential functions. What do you mean by the exponential functions? By the way, the most essential learning competencies that we are going to tackle today are exponential functions, how to represent it in real life situations, distinguish, oh wait lang, sorry, this is logarithmic. Let me go to this one. So we have to know the concept of exponential functions, represent them in real life situations, define exponential function, equation, and inequalities, distinguish among exponential function, equation, and inequalities. You have to solve them as well, and we have to graph them using table of values, and also find the domain, range, intercepts, zeros, and asymptotes of an exponential function. But that's too many, so inshallah we will just tackle the first parts, which are lesson 1, 2, and 3, inshallah. But still, no, we're still going to graph the exponential functions, and we are still going to determine the domain and range. So I think we can do it in one go, inshallah. So in your modules, I hope you have seen your modules. We have already posted that a long time ago, actually. So just a little bit of reminder or review. I hope you can still remember the laws of exponentiation. You have taken that in grade 10 or grade, if I'm not mistaken, grade 7. So I will be sharing my entire screen. And if you have any other questions or if you have something to clarify, just use your microphone because I will not be seeing the chat box for a while if I am sharing my entire screen. So review on exponentiation, if you can still remember, no? Laws of exponentiation or exponents. So the first one is any number raised to the power of 0 is equal to 1 for any numbers, real numbers I should say, except 0. Why? Because 0 raised to the power of 0 is undefined. Okay? And then any number raised to the power of 1 is itself the same number. Also, a raised to m multiplied by a raised to n is just the same as a m plus n. Also, a raised to m divided by a raised to n is just the same as a m minus n. This is the case if m is greater than n. However, if, for example, if m is less than n, then this functionality or this rule changes. It should be a to the power of n divided by a over n. It should be 1 over a n minus m. ma-reciprocal siya. Okay? And then, one of the most important rules in exponents that we have to bear in mind is the a to the negative m is equals to 1 over a to the power of m. And that is actually the reason as well, the base reason for this one. Nag-reciprocal siya at nag-change or nagbago ang arrangement ng n at saka m because of this concept. You have to bring it down and change the sign because whenever the exponent has a exponent on the denominator, mas lalo actually lumiliit ang value nung number na yon. So that is why you have to exchange the signs and reciprocal ang kanyang arrangement. Those are only a few of the law of exponents. I'm sure you have tackled all, if not at least 3 perhaps, or at least some of this in junior high school, inshallah. And if you haven't, then I really hope that you can review that one. Actually, nasa modules nyo rin. Nakalagay din doon ang laws of exponentiation. So what is an exponential function? So by theory, actually, any expression with an exponent is can be an exponential function. But the technical definition is an exponential function with base b is a function of the form function of x, b to the power of x, where b is greater than 0 and b is not equal to 1. So what do you think is the reason why the exponential or the base b in an exponential function should not be, should be greater than 0 is because we have already established here, that if the base is 0 and it is raised to any number, actually, it's just 0. And also, if the number 0 is raised to the power of 0, it's also undefined. Okay? Now, why does it not to be, bakit hindi siya pwedeng maging 1 naman ngayon, is that, remember the module 1, we have stated there different types of functions. And just imagine if you have y is equals to 1 to the power of x. So, any number, itong x na to, it could be any number. The answer is still 1. Okay? Tama man? 1 to the power of 1 is 1. 1 to the power of 2 is 1. 1 to the power of 3 is 1. 1 to the power of 1,000 is still 1. So, it cannot be this way. It cannot be an exponential function. Why? Because it's going to be under a very specific type of function, which is, kung maalala niyo pa sa module 1, it is called the constant function. Okay, so that is why the specific conditions for an exponential function with base b to become an exponential function is this function of x is b or to the power of x, where b, the base, is greater than 0 and it is not equal to 1. So that is the technical definition of an exponential function. So you may ask, teach, so what are the real life examples? Saan ko ito magagamit sa aking buhay? You may ask that one. So anyway, I think all of us, if not all, most of us have already experienced getting the chain letter message. Like it's a message or a text message or any type of message, an email perhaps that says short message or something of a message. It has a content, and then at the end of the message, it says, send this to another 10 people or send this to another 20 people. So that is the chain letter. So whenever I tell you, if you can still remember, whenever we discuss in MIL, I keep on telling you that be careful in posting or retweeting or sharing things on Facebook or retweeting posts on Twitter. Why? Because the effect of this is actually exponential. It's exploding. How? Okay, let's say, for example, person A. This person sends a chain letter to 10 people, for example, only. Now, these 10 people, because the first person who sent the chain letter wants those people to send it to another 10 people, right? So, let's say this is initial P time. whatever that time may be. It might be on the first day, it might be on the first week, it might be on the first month. Depende, no? Depende so kung anong time yan. But lately, these days, because of the new technology, like for example, in Twitter, it might be 1 second. When the first person just clicked and posted a certain chain letter, it might be 1 second, and then on the next second, no? Depende ang time dito. But just a reminder, it's ang T dito ay nagre-represent ng time. So let's say at the first time, initial time, 10 ang gisend niya. Now, itong 10 tao na to nag-send naman sa another 10 people. Now, this is where you see the explosion or the exponential growth of the message. Because 10 times 10 now is 100. So yung nagsimula na 10 messages nitong si person A is now 100 messages out there to different people. Now, syempre kasi diba nandoon sa message, send this to another 10 people. Now, this 10 people na naman will send it to 10 other people. Now, 100 times 10, ilan na naman yun? 1,000 now. And these thousands again will send it to another 10 people. So how many is that? 1,000 times 10, it will become 10,000. So you see, from 10 messages, it explodes. That's the exponential growth. It explodes to 10,000. That is why, again, as a reminder, be careful on what you share on Facebook, Twitter, because ganito karami. What if, no? We don't know. What if you just merely share things, and what if that is an misinformation or a malinformation or fake news? Tapos gi-share mo, and then you just didn't know that you have like at least 10 followers. So 100 na next ang fake news na na-spread. So it's not good. Okay, so this is an example of how things grow exponentially, and one of the applications of this is the Twitter, no? And the sharing system of Facebook. So we have to be careful what we are sharing online and posting online. So another example will be the binary function. If I'm not mistaken, I've already told you this. I forgot when, but the binary function of the basic foundation of computing, computer science, is the binary function, which is, if you can still remember, there is only 1, 0. That is the only language that can be understood by the computer, 1 and 0. So, ang binary function actually is that this 1 and 2, so you have 2 characters, so 2 to the power of x yan actually ang binary function. Okay, now if you want to get the gist of how this is being used, for example, you have a certain character, like for example, let's say, di ba nga, 2 to the power of 0, it's just 1. And then 2 to the power of 1 is 2. And then we have 2 to the power of 2 is 4. And then 2 to the power of 3 is 2 times 2 times 2, 8. And then we have 2 to the power of 4, 2 times 2, 4 times 2, 8 times 2, 16. So, ganun siya, no? So, kung marirealize ninyo, that's actually how RAM, the random access memory, and the storage devices of any type of storage devices are labeled. So, nag-start siya sa 1, which is 1 gigabyte. And then, nag-start siya. And then, next is 2, no? And then, next is 4. And then, next is 8. And then, next is 16. And then, next is 32. Tama ba? 16 times 2, 32. 2 to the power of 6 is 64. And then, 2 to the power of 7 is 128. Tama ba? If you have calculator, you can check. 2 to the power of 9 is, what is that? 256. Oh, no, 512. Tama ba? 512. And then you have 2 to the power of 10 is 124. So, actually, ito siya, guys. That is already 1 gigabyte. Okay? So, ito ang ginagamit na functionality ng binary language. Which is, by the way, a very basic concept. Let's try to graph that one. let's try to graph the binary function. So, kung hindi tayo masyadong expert sa pag-graph, then let's just use the table of values, just like how we have been doing for ever since the start of this subject, no? So, for example, we will use -3, -2, -1, 1, 2, 3, and then ilalagay lang natin siya dito sa ating function. So, if x is equals to -3, so 2 to the power of -3, that is equal to 1 over 2 to the power of 3. So that is 1/8. Now, kung -2 ang x, that is 1 over 2 to the power of 2, so 1/4. And then kung -1 ang x, that is 1/2. Any number raised to the power of 0 is 1. And then 2 to the power of 1 is just 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. Now, that we have this table of values, we can now simply plot the coordinates. So, maggawa tayo dito ng Cartesian Plane, no? And then we have, this is your x, this is your y, okay? Then we have -1, -2, -3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Okay, sorry, lampas. Now, if -3 ang x, it's 1/8. 1/8 is like, I don't know the decimal point, but somewhere over here, no? Pag negative na naman, it's 1/4, so somewhere over here. If it's -1, it's -1/2. Sorry, 1/2 positive. And then if it's 0, it's 1. And then if it's 1, it's 2, 1, 2. If it's 2, it's 4, 3, 4. If it's 3, it's going to be 8. So dito na siya banda. Anyway, so if we are going to extend this one, bigyan kanya ng itsura niya, no? Okay, extend yan siya. So as you can see, that is the form of this graph. Itong fx, or function of x, is equals to 2 to the power of x. So some things that we can analyze from the graph itself is the domain, no? Because this extends to here, and this extends to up to, it's going to be exponential. So your domain is obviously all real numbers, -infinity and +infinity. So that is all real numbers. However, your range now is going to be different, no? As you can see, bakit hindi siya nagta-touch dito sa bakit hindi siya nag-touch sa x-axis? That is because kahit gaano pa kalaking negative number ang ilagay mo dito sa function na ito, it will still yield a positive result. You just try, guys. You have your calculators with you. If you have your scientific calculators with you, try 2 to the power of -100. It's still going to be a positive number. I'm trying that with my calculator right now. It's just a very, very small number. It's 0 point something to the power of 10, -31. That's a lot of zeros, and that's a very small number. But still, no, hindi siya nag-abot ng 0. So, hindi talaga siya ibig sabihin mag-touch dito sa part na ito. And remember, in rational functions in module 2, what is that thing that cannot be, walang intersection doon at hindi siya nagta-touch sa function? That is what you call the asymptote. So, meaning, for this one, the asymptote, or the horizontal asymptote, to be exact, the horizontal asymptote is y is equals to 0, or that is the x-axis itself. Okay? Now, what is the vertical asymptote of this? No? Unlike sa rational functions, pwede mo siyang isolve. But for this one, as you can see, the domain itself is -infinity to +infinity. So, mag-i-intersect siya sa kahit anong spot ng x, right? So, meaning, you do not have a vertical asymptote for this type of exponential function. Okay, so one other things that we can analyze, or we can conclude from the graph, is that as x, as the value of x approaches +infinity, then it really, the number or the resulting number becomes so big. Okay, just look at the jump, from 4 hanggang 8 kaagad. And remember, pag gisunod pa natin to, no? Pag 4, ang ating x, it will become 16. So the jump again, ang layo ng 8 sa 16, right? At kung itutuloy pa natin, 5 magiging 32. Ang layo ng 32 sa 16. So the jump is really, the gap, I should say, is really wide. Okay? So as x approaches positive infinity, the resulting number becomes really big. Okay? Now, the other way around of that is that as x approaches negative infinity naman ngayon, no, it will become something like this. It's a very big number. Yung kanyang positive pa rin or negative, no? Itong nasa ilalim niya. And the resulting is a very small number, but still positive. Okay? So that is the some of the things that we can conclude from the graph of a exponential function. Now let's try this one. Remember, this is a function of x, 2 to the power of x, no? Let me see. Give me one moment. I'm going to go to the next clear screen. Okay. So let's try this one. The opposite, or not exactly the opposite, but the reciprocal of 2 to the power of x. So let's say function of x is equals to 1 over 2 to the power of x. What do you think will be the graph of this one? If you have any ideas, you can use the chat box for your answer. Ano sa tingin nyo ang magiging graph ng reciprocal ng 2 to the power of x, which is function of x is equals to 1 over 2 to the power of x. You can use the chat box for your answers if you have an idea. So let's say, no, table of values pa rin tayo. Sorry. Table of values pa rin. So let's try to use negative 3, negative 2, negative 1, 0, 1, 2, and 3, the same as what we did earlier. And now, substituting the values. So, ito siya, no? Itong negative 3, it will become 2 to the negative 3. Now, negative na naman siya. So, di ba, i-reciprocal mo yan ulit? So, magiging ganito siya, no? Which is the same as, ganyan na lang siya. Okay? Sorry, hindi dapat to negative. I'm sorry. It should be something like this. It should be positive now because reciprocal na natin siya. Which is the same as this, right? So, meaning, this one, ang kanyang values, will be the opposite of the ones that we have above. Ito na part. So, itong negative 3, it will become 8. Itong negative 2 will become 4. Negative 1 will become 2. This is 1. This is 1/2. This is 1/4. And this is 1/8. You try to solve on your own, guys. You try to just substitute the values of x to this function. You will get the same results. Okay? Now, let's try to graph this one so that makita natin kung anong itsura niya. Meron bang nagsagot sa inyo? May idea ba kayo kung anong magiging itsura niya? Is it going to be a mirror of the graph of function? Is it a function of x is equals to 2 to the power of x? Or is it going to be a different type of reflection? Is it going to be reflected on the right side? Or is it going to be reflected downwards? What do you think? You can use the chat box for your answers. Anyway, so now we are going to plot this one. So again, Cartesian plane, automatic. This is your x-axis. This is your y. So negative 1, negative 2, negative 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so if it's negative 3, it's going to be 8. Kung negative 2, it's 4. This one. Kung negative 1, it's 2. Kung 0, it's still 1. Dito pala. Okay. And then if we have 1, it's 1/2. So somewhere here. And then kung 2, it's 1/4, somewhere here again. And then kung 3, it's 1/8, somewhere here. So it's a different type of reflection, no? It is reflected on the other side. Still though, on the first and second quadrant, nasa taas pa rin, no? Nandito itong first quadrant natin, di ba? First and second quadrant, nasa baba yung third and fourth. So still, it's on the first and second quadrant. So ibig sabihin, ang kanyang range is the same. No, ang kanyang range is still 0 to positive infinity. Tama man? Remember guys, the range is the set of y values of a function. And obviously, your domain is still negative infinity to positive infinity, which is all real numbers. So, as you can see, that is how reciprocal looks like, no? Parang, it looks like a mirror. Binaliktad mo lang talaga siya. In fairness, no? Anyway, so the same way, ang horizontal asymptote natin dito, horizontal asymptote is, as you can see, still the x-axis. And looking at the domain, wala pa rin tayong vertical asymptote. So vertical asymptote is still not applicable. Okay, so anyway guys, baka isipin niyo, is this always the case, Peach? Pag ang automatic ba na ang horizontal asymptote is the x-axis? Is it always the case? Not exactly, no, and not entirely, because which, what do you call this one? Exponential functions actually have what we call transformation. Transformation. And what is a transformation? So a transformation actually is nag-iiba lang yung status or yung itsura ng ating exponential function. So let's say that b be a positive number, not equal to 1. Guys, nasa ano nyo rin to ha? Nasa module nyo rin ito siya. A transformation of an exponential function with base b is a function of the form, ganito ang form niya, function of x is equals to a times b, x minus c, plus d, where a, c, and d are all elements of the real numbers. Okay? So, ganito na ang magiging form niya. But not all the time ganito ang form niya because what if, for example, a is equals to 1? If a is equals to 1, then parang magiging ganito lang ang itsura niya. Tama man? Okay, so depende, no? We have to be careful of how to look at the form of an exponential function. So for example, let's have an example and let's try to graph it as well, inshallah. So let's say, sample, we have a function of x is equals to 3. So sabihin natin, ang a natin this time around is just equal to 1. So ito siya ang ating base. To the power of x plus 1. So, ang ating c is 1. Minus 2, ang ating d is negative 2. Now, as you can see, itong negative 2 actually, this already implies your horizontal asymptote. Horizontal asymptote. It will become y is equals to negative 2. Later on, pag mag-table of values tayo, you can still see, no, na hindi niya talaga matouch ang y is equals to negative 2. And also, this one, itong ating C, it actually implies kung saan nag-shift yung ating graph. In this case, x plus 1, it actually means that the graph will shift 1 unit to the left. Okay, so para makita natin kung anong magiging itsura niya, let's just try to graph it. So, table of values tayo ulit, no? I hope you still have your calculators with you so that you can try to solve for the table of values as well. Let's use negative 3 pa rin, no? Negative 3, negative 2, negative 1, 0, 1, and 2, and 3. Okay. So, kung negative 3 ang value ng iyong x, it will become 3 to the power of negative 3 plus 1 minus 2. So, negative 3 plus 1 is negative 2. So, negative 3 minus 2. Negative 3 to the power of negative 2 is just 1 over 3 square. So, that is 1 over 9 minus 2. Okay, pakicalculate. Pakicalculate na lang guys. 1 over 9 minus 2. Let me use my calculator as well. Okay, well, it's actually negative 17 over 9. Now, you might ask, Teach, sabi mo walang negative. Kanina, hindi tayo nakakaabot sa negative part sa baba, sa third quadrant. Well, that is because this is a transformation. Okay, meron na siyang D part. No? Meron siyang letter D dito na part. And that's why it is called a transformation. It is not the basic exponential function form. Okay? So, kaya tayo nagkaroon ng negative na y value is because of this part of the exponential function. Now, pag negative 2 naman, guys, I just actually computed it beforehand. So, it's negative 5 over 3. You can try it on your own, no? It's simple. And then, kung negative 1, it's still negative 1. Any number to the power of 0 is 1. And then, 1. Kung 1 naman ang iyong x, it will become 7. If it's 2, 2 plus 1, 3 to the power of 3, okay, 25. And then we have 3, so 379. Medyo mahaba yung graph. Oh no, no? Medyo malaki ang graph because we have 79. So let's try to make it as simple as it can be. So kung i-graph natin ito guys, this is your x, this is your y, which is kulang probably kasi nga meron tayong 79, but okay. Let's just try this one. So 1, 2, 3, and then we have negative 1, negative 2, negative 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, anyway. No? So let's try. If it's negative 3 over, if it's negative 3, ang ating y is 17 divided by 9. That is 1.88. So negative 1.88. Sorry, dapat pala meron tayo dito sa baba. So negative 3 is negative 1.88. So something somewhere over here. Dito na part. Pag negative 1 naman, it's 5 over 3, which is 1.5. 2.5? Wait lang. 5 divided by 3 is... okay, 1.5 nga. I'm sorry. It's 1.67, I should say. 1.67, somewhere over here siguro. And we have negative 1, also negative 1. And then 0 and 1. So 0 and 1. So dito na part. And then 1 and 7. Okay, 1. 1, 2, 3, 4, 5, 6, 7. Dito siya na part. And then ang 225 masyado ng mataas, no? So, ibig sabihin basta pag ganito ang ano niya, no? Ang graph niya. Okay, pag ganyan. Mataas. Okay. But as you can see, no? This is negative 1.8. This is negative 1.66. This is 1. So, hindi rin yan siya mag-touch dito sa asymptote natin, which is what? Y is equals to negative 2. Ito na part, no? Itong negative 2 na ito, itong horizontal asymptote na ito. So, by the way, guys, the domain is still all real numbers. But the range now is different. Why? Because the range will now include, not exactly include, but will start at negative 2 to positive infinity. Guys, remember yung ating set notation, di ba? Pag parenthesis, it means hindi siya kasali. Pero kung square bracket, it means kasali yung value niya as a solution. But in this part, it is not included. However, it starts there. Okay? So, kahit try nyo pa guys, kahit kayo pa mismo ang mag-try, let's say itong negative 3, let's say you will have negative, I don't know, 100 something or negative 1,000. Still, it will not reach the value of negative 2 for the y. It will not. Kasi nga, it will never touch, no? Ang horizontal asymptote, the graph of the function will never touch or intersect with that horizontal asymptote. Anyway, so vertical asymptote, because the domain is all real numbers, then ang ating HA is equals to negative 2. Ang ating vertical asymptote is still not applicable. Okay? So that is an example of a exponential function with transformation. Now, we also have a different type of exponential function, which is called the natural exponential function. It's actually almost the same as the normal or the basic form of an exponential function. It's just that the base is letter E. Have you encountered letter E in your previous mathematics lessons? Itong si letter E, the natural number. I'm not sure if na-encounter nyo na ito siya in your previous mathematics lessons. However, the value E is the same as pi. Para siyang, it's a constant number and it actually has a value. And it is estimated, yung kanyang value actually is estimated to be 2.71, 2.71828. Yun ang kanyang estimated value. It's not exact. Just like pi, maalala ninyo ang pi is 3.14, 15, 16, something. No? So, and these numbers, guys, are actually an irrational number. Kung maalala nyo pa yung nireview ko sa inyo ng module 1, irrational numbers, there are different types like non-repeating, non-terminating, repeating, non-terminating, yung mga ganon, no? So this actually, pi and the natural number is an irrational number, and they are non-repeating, non-terminating numbers. As you can see, no, yung kanilang decimal parts, walang nagkasunod dyan na numbers. It's non-repeating. And then it's non-terminating kasi ang dami, actually, like, I don't know kung na-solve na yan ng tao. Maybe computer ang nakasolve, no? Ng ilang decimal places niyan. Pero hanggang yan siya, it does not terminate. The same as the natural number. And just a little bit of a information about the natural number. It was actually solved by Leonard Euler. And actually, Euler is one of the greatest mathematicians to live, along with, yung mga tao talaga na magagaling sa math. Like, for example, si Fermat, sila Lagrange, sila Leibniz, no? And his concepts were actually used not just in, what do you call this one, computer science, but also in engineering, physics, quantum mechanics, chemistry, and a lot of things in the field of science and medical science even. So Leonard Euler, this is sometimes also called, itong natural E na ito, is sometimes also called the Euler's number. Dahil nga siya ang nakahanap ng number na ito. Also, sometimes, no, ito rin ay tinatawag na natural base. Ang daming tawag sa number na ito, no? But this E is just the natural number, and it's actually used in a whole lot of things. Unlike pi that is only, not exactly only, but is mostly related to circles, ang natural number is related to a lot of things. Okay? So the natural exponential function, ang kanyang definition is also in your modules. I hope you have read your modules. So the natural exponential function is a function defined by this form. Function of x, ang base niya is the natural number to the power of x. For all x are real numbers. Guys, again, no, hindi tayo muna magpupunta sa high or advanced level of mathematics. We are just dealing with real numbers. Although at some point, no, we have already dealt with irrational numbers, but with complex numbers such as imaginary numbers, we cannot deal with that yet. So an example of a imaginary number is like this, no? Because this will be something as -1 over, parang ganito ang magiging itsura niyan. And this one, meron niyang solution. I-try ninyo sa mga calculator ninyo, it has a solution. But this one, it doesn't have a solution yet. Not yet, no? It's an imaginary number. So we will not tackle that. So meaning, ang x natin should be all real numbers. Negative infinity to positive infinity lamang ang pwede niyang maging value. Now, let's try to solve, no? Like for this one, let's try to graph para makita natin kung ano itsura niya. But if you will see the graph, it is basically and technically the same as any other exponential functions. Why? Because e is 2.718. It's a real number, no? It's just a real number. It's almost the same as 2, and if you approximate it, it's almost the same as 3. Tama man? So if we're going to give a table of values for that one, let's just use -1, 0, and 1. So using your calculator, guys, kasi hindi natin to siya manual na solution, no? So I'm not sure what is your calculator, but my calculator is Casio FX-570ES. So ang natural number ko can be found near pi. So I'm not sure about your calculator, no? So if you are using a different type of calculator, usually meron dyang nakasulat or meron dyang symbol na letter E na parang what do you call this one, italicized. Sometimes then it is what do you call this one, you have to push the button of shift first para makuha mo yung value niya, just like the pi. Or kung mas maganda yung mga calculators ninyo, sometimes you have to push the button of alpha and then the natural number sign. It really varies with different calculators, okay? But my calculator, nasa baba siya banda, katabi ng equal sign. So, So, natural e to the power of -1. Apparently, ang sagot ay 0.3678. Okay. 0. Let's just get the first two decimal points. 37. Kung 0 naman, e to the power of 0, so it's 1. Again, any number, no? To the power of 0 is equals to 1. And then, if it's to the power of 1, of course, itself. So, 2.7, 1, okay, 72 na lang. 72. So, if you're going to plot that, okay, another Cartesian plane, x, y, so -1, 1, sorry, 1. So, kung -1 ang value niya, it is 0.37. So, I think that is somewhere over here, kunwari, no? And then pag 0, it's going to be 1. And if it's 1, it's 2.72. So, andito siguro siya. So, as you can see, it's almost the same as the 2 to the power of x na graph, no? So, almost the same. There's really nothing too much of a difference, no? It's just that the base is the natural number. Okay, later on, guys, pag mapunta na tayo sa logarithmic functions, I think we will understand better how important the natural number is. Okay? So, by the way, looking at the graph, so the same, no? Ang ating domain is still all real numbers. And our, range, ang ating range is still 0 to positive infinity. Now, actually, guys, ang natural exponential function also has a transformation. Okay? So, let's try, para madali lang na example. Lagyan lang natin siya ng d, -1. Okay? So, remember, itong d, no, sa ating function, sa ating definition of a transformation, dito na part, this d, no, yan yung sinasabi kong d. Okay? So, this part will tell you the horizontal asymptote. So, obviously, automatically na, y is equals to -1. Okay? So, kung ipa-plot natin to, okay, mag-table of values muna tayo. Let's say, ang table of values lang natin is -1, 0, and 1. Parang tulad lang din sa taas. And then, I'll be using my calculator. So, EX. But if you can, pero kung ma-realize nyo guys, no? We can use this one, these values. Minusan lang natin ng 1. Tama man? Am I right? Because you're just deducting 1 to e to the power of x. In which case, e to the power of x, nakuha na natin dito, di ba? Ito yun sila. So we just have to minus 1 everything. Am I right? Okay. So now, using your calculator, it will be 0.37 minus 1 is, let me still use my calculator. Okay. Okay, that's negative 0.62. And then 1 minus 1 is just 0. And then 2.72 minus 1 is 1.72. Now, let's plot this. Guys, if you really want to check kung tama yung mga pinaggagawa ko dito, you can simply substitute the x values to the function that we have here. Okay, so this is your x, this is your y, and then like positive 1, -1. So kung -1, it is negative 0.62, okay. So negative 0.62, it's like almost here, no? Let me use a different color. Parang dito na part. And then 0, 0, okay. And then 1.72, 1.72 dito na part. So as you can see, it just shifted 1 unit below. Ayan. Almost the same as the graph earlier, pero nagbaba lang siya. Tama man? And also, the asymptote is now y is equals to -1, which is this part. Okay? So, ganun lang siya kasimple, guys. So, just treat, huwag masyadong magpahirap sa sarili, no? Just treat the natural number as any other number. It's a real number, actually. So, in your modules, if I'm not mistaken, you will see there some natural or real-life examples of how exponential function is being used. By the way, guys, kasobra na ako masyado sa time actually, no? But is it okay because I saw your schedule and the next part of your next schedule, I should say, is just a continuation of your modules and whatnot. Is it okay to continue up until 11? Let's just solve, or let's just try to represent exponential functions in real life. Like, for example, let's tackle the population growth, radioactive decay, and the compounded interest. Okay lang ba, mga ano? Okay lang. Is it okay, students? Okay, inshallah. How about the others? But I hope you have read this, no? Your module. I hope you have at least skimmed your modules. Okay. So anyway, some of the things or some of the natural phenomena, observations that we can apply exponential functions is nabanggit ko na kanina yung sa computer science or information technology, which is the binary function, and a whole lot more, guys. Actually, the concept of exponential function is everywhere. Even in engineering, no, we can say that it is being used in engineering. Why? For example, if you built an establishment, a building, and then a 6.6 magnitude of earthquake strikes the building, and the engineer says that it will be weakened exponentially with the stronger the magnitude of the earthquake, it will be weakened exponentially. So makukompute niya nung engineer kung kailan na kailangang i-renovate or i-restructure yung building. So it is also for safety precautions, no? So maraming buhay ang masisave. For example, if the engineer uses the concept of exponential function on design and structure, as well as medical sciences. Medical sciences or community health sciences, no? Because, for example, the spread of COVID-19 virus, no, is exponential growth, no? Kung makikita ninyo, di ba nga, kung isang asymptotic na tao, nakahalubilo niya ang another 10 tao, those people do not know that they might be asymptotic as well. And then these 10 people will then again intermingle with another 10 people. Now the same concept. It is exponentially growing. So a whole lot of things actually. So one of the things that is in your module, an example of the real life use and application of exponential function is the population growth. I think it's on page, wait lang, I forgot what page that is. Here you go. No? So, on several instances, scientists will start with certain number. Usually, ginagamit ito sa bacteria, guys, or virus, or pagkalat ng virus. Ito usually yung ginagamitan ng mga exponential functions so that they can model how it will be in the next hours, perhaps, or next days, or next weeks, okay? So, let's have this example. T is equals to time in hours. So, T is time in hours. So, by hours siya. There were initially 20 bacteria, kunwari, whatever that bacteria may be. And then suppose that the bacteria doubles every 100 hours. So, times 2 every 100 hours. So, give an exponential model for the bacteria as a function of T. So, we are now looking for function of T. Again, T is the time in hours. So, initially, no, T is equals to 0. Initially, you have 20 bacteria. Tama man? Now, let's say, it now passes. Hindi tayo pwede maging T is equals to 1 because nga, every 100 hours siya nagadoble. So, let's say, 100 hours has passed. Ilan na ang population ng bacteria? We will have 20 times, because it's times 2, so 2, to the power of 1. Because kaisa pa lang siyang cycle na nag-increase yung kanyang population. Tama man? But remember, guys, again, so let's say 20 bacteria we have now, so result, for example. So remember, 2 to the power of 1 is just, sabi no, ginamitan ko pa ng calculator. It's just itself. So it's almost the same as 20 times 2. Ayan. So 20 times 2 is 40, tama ba? Yes, okay. So let's say 200 hours na ang nakalipas. So 20 na, 2 to the power of, ano na siya? 2. Which is 2, or kung hindi ko good gamitan muna siya ng exponent, it will be like this, no? Kasi ang exponent, like for example, 2 to the power of 3 is the same as 2 times 2 times 2. Tama man? Or let's say, sabihin natin, kung 2 to the power of 4, this is also the same as 2 times 2 times 2 times 2. Okay? Pero hindi ko na yun gamitin, guys, okay? Kasi, sorry. Ang dami nating isusulat kung ganun, no? So, let's go ahead and just put in the exponent form. So 2 to the power of 2 na siya, which is 4. So 4 times 20, wait lang, kailangan ko ng calcu. Ayan, 80. Now, on t is equals to 320.2 to the power of 3 na siya. 2 to the power of 3 is 8. 8 times 20, 160. Tama ba? Correct me if I'm wrong, guys. Okay, so you can, from this table that we got here, let's say t to the power of n, like let's say t to the n hours. Kunwari, hindi natin alam kung ilang hours ang nakalipas. So meaning it will become something like this. And that is the result, which is the function itself. So meaning if you're going to create an exponential model for this situation, it will be something like this, 20 times 2 to the power of whatever the t is, whatever how much time has passed. No? So that is the population growth. Now, depende, no? Kasi itong 2, specific na kasing sinabi dito na it doubles. It increases twice as the original. But there are times, no, depende sa bacteria or depende sa virus, sometimes it's not only twice as much. Sometimes it is 10 times as much or 15 times more or 20 times more. Depende sa bacteria, no? So, meaning this one, it could be a variable as well. And of course, this one is also a variable. Specific kasi dito sa problem na to na 20 ang starting population ng bacteria. But it can be anything else. Like for example, it could be 0. Or let's say it could be 1. Only 1 bacteria. Or let's say it could be 10 bacteria. No? Depende. So this part can also be a variable. So that is how you use this exponential model to compute any type of population growth. Depende. Now we also have radioactive decay. So, just a little bit of review in your chemistry. Di ba nga, meron tayong mga elements dyan na radioactive, like for example, uranium, plutonium, neptunium, zirconium. Karamihan ata ng mga nium. Meron yan silang radioactive decay. Radioactive yan sila. And there is what we call the radioactive decay. So, depende, again, no? But these elements actually have half-life. Actually, kahit ang vitamin C, guys, it has half-life. Kaya nga pansinin nyo, pag slice nyo ng mangga, iiwan nyo lang ng konti, nagapangit ng itsura niya. Why? Because the vitamin C decays. And it is half-life. So, pag mag-open kayo ng mangga, kainin nyo kaagad to get the 100% vitamin C in there. Kasi kung hayaan nyo pa yan, sayang yung half-life ng vitamin C. Mamatay kaagad yung kalahati niya. Okay? So, there is always a, what do you call this one? Half-life of any type of radioactive na elements. And if this is increase, no, ang population growth is something about increase of population, ang half-life is obviously a sample of decreasing population growth. So let's have an example here in your module. Okay, so the half-life of a substance is the time it takes for half of the substance to decay. So let's have, suppose the half-life of a certain radioactive substance is 10 days, and there are 10 grams initially. So A, determine the amount of substance remaining after 30 days, and B, give an exponential model for the amount remaining substance. So sabi niya, ang half-life nitong substance na to ay 10 days. This is specific for this problem, ha, because different elements have different half-life. Tapos ang initial niya na amount is 10 grams only. So how can we determine daw, ilan na lang daw ang natira after 30 days? So how can we solve for that one? So, gawa din tayo ng table siguro, no? So initially you have 10 grams. So, after 10 days, kasi nga, so ang T natin dito guys are days, ha? So, after 10 days, 10 divided by 2, no? Or times 1/2. So, that is equals to 5 grams. And then, after 20 days, so, ito naman ngayon yung ating magiging amount na ngayon. So, 5 times 1/2, which is 2.5 grams. And then, on 30th day, itong 2.5 na natira, mag 1/2 na naman siya, and it will be 1.25 grams. So meaning, no, on the 30th day, after 30 days I should say, 1.25 grams na lang ang natira sa substance na ito. So how are we going to create the exponential model for this one? Exponential model. So looking at the table that we have here, kung mag-create tayo ng function t, so kailangan meron tayong initial quantity. In which case, yung initial quantity dito is 10. Tama man? And then it times natin siya sa 1/2 because it's half-life. And then we have raised to the power of t, the time it takes, ito. Okay, yan yung ibig sabihin ng t dyan. Divided by the initial or the half-life, the time it takes for it to be halved, which is 10 days. Specific lang din dito sa problem na ito. So meaning, kung ibang problem ang isi-solve natin, this part should be a variable. This part can change as well. So variable din yan siya. That is why, kung makita nyo dito, ang model actually ng half-life is actually in your modules. Lahat, no? Nasa modules niyo. Ito, y is equals to y sub 0, which is the initial value, times 1/2 to the power of t over t. Capital letter T. Okay? So that is how that model is, dyan nakuha yung model na yan. By the way, guys, itong 1/2 na to, no, is very specific to half-life. Meron kasi mga ibang bagay na nagde-decrease, hindi half-life. Minsan nagde-decrease sila at a rate. No? At a rate. For example, yung mortality rate ng Philippines, di ba? It's a, like, let's say 10% or 10.2% or 0.02%. So sometimes it is at a rate. So meaning, this half here, this 1/2 here, is specific to half-life, but you can also use the same exponential model for other population decrease that you want to solve, pero palitan mo ito siya ng rate, kung gaano kabilis ang pag-decrease ng population na yon. Okay? So, really, creating mathematical models will be able to help you in solving almost any other problems. We just really need to have analysis, and of course, no, pasanayan lang yan. The more math problems that you solve, the more you understand these things. Last but not the least sample that we have here is compound interest. And by the way, guys, this is only for your information. We are not encouraging you to go ahead and invest in this kind of things. This is not good for us, no? This is riba, yung interest na yan. So this is only for your information that exponential functions are being used in these concepts. So anyway, dito tayo, balik tayo sa module natin, compound interest. You can read the meaning of compounded interest. Ang ibig nga namang sabihin dyan is you have a principal amount, there is a rate, depende no, sa bank or sa any type of establishment or a company that offers this kind of services, depende sa kanila kung ano yung rate na yon. And then you times that rate or you multiply that rate to the principal amount that you have, and that value will be added to your principal amount. So, tumataas ang pera. Yun na nga yung sinasabing tubo. No? Tumutubo ang pera on its own. And also, depending on the establishment that you are, that you have, no? Depende. Yung pagtaas niya ay, it varies as well. It can be annually, it can be quarterly, it can be semi-annual. So, depende rin yun siya lahat. Now, we have an example here. Mrs. Ali invested 100,000 in a company that offers 6% interest compounded annually. Define an exponential model for this situation. How much will this investment be worth at the end of each year for the next 5 years? Ooh, okay. So, let me just copy that one. Para, madali tayo. So, si Mrs. Ali daw ay nag-invest ng 100,000. So, meaning, the ang rate natin is 6%, which is in decimal point, that will be 0.06. Define an exponential model for this situation. Okay. So let's have a table again. So at t is equals to 0, which is annually, no? So ibig sabihin yearly, nagataas. So, ang amount ng pera ni Mrs. Ali ay 100,000 pa lang, no? So, let's say after a year, ang kanyang magiging amount na is 100,000 plus 100,000 times 0.06. Tama man? Now, as you can see, kung mathematical ang pag-iisip natin or kung titignan natin siya in a mathematical stance, this one and this one is common, kumbaga pa. So, let's factor that out. Kung i-factor out natin siya, it will become something like this. Ilabas natin ang 100,000. So, merong 1 dito na natira plus this one, 0.06. Tama man? So, that is now your amount for the first year. Kung i-calculate natin, 1 plus 0.06 plus, times 100, 1, 2, 3,000. So, at the first year, si Mrs. Ali ay meron ng 106,000 pesos on her account. So, tumubo yung pera by 6,000. That's a lot. Now, on the second year, syempre ito na yung ating magiging principal amount. Tama man? Kasi yan na yung nandoon sa kanyang account. So, and remember, the 106,000 is also this. Okay? So, meaning, on the second year, it's going to be something like this. Okay? Plus, ito siya, kasi ito na yung principal amount. Ito siya mismo. I-times na naman natin by 0.06. Tama man? Ito na, ito ba, kung baga pa, siya na yung kukunan natin ng 6% para idagdag sa amount ng account niya. Okay? Now, titignan na naman natin siya mathematically. This is the same as this. So, i-factor out na naman natin siya. Pag factor out natin sa kanya, it will be 100,000, 1 plus 0.06. May isa na namang natira dito, no? So, 1, and then plus, and then ito, 0.06. Now, as you can see, ito siya na part. This is the same as 2 times 2 times 2 times 2. Tama man? That is the same as 2 times 2. Which is, this is the same as 2 square. Tama? So, meaning, this part right here, you can simply write it as 100,000, 1 plus 0.06 square. Okay? At solve natin siya. So, that is 1 plus 0.06 square times 100,000 is equals to 112,360. So, tumaas na naman ulit ang pera ni Mrs. Ali. Now, on the third year, okay, ito na naman siya ang ating magiging principal amount, no? Which is this. Okay? But hindi na natin pahirapan ang sarili natin because we know that it will just add 1 plus 0.06 there in the function, in the mathematical model, I should say. So, idiretso na natin siya na gawing exponential function. So, to the power of 3 na siya. So, on the third year, it will be 1.06 to the power of 3 times 100, wait lang, 100, 1, 2, 3,000. Ayun, so nagtaas na naman ulit ang value ng kanyang pera at 119,101.6. Okay, now on the fourth year, it is going to be to the power of 4. 1 plus 0.06 to the power of 4 na siya. So, 1.06 to the power of 4 times 100, 1, 2, 3,000. So, 126 na ang kanyang pera. 247. And then, on the fifth year, because in the problem, it says, how much will this investment be worth at the end of each year and for the next 5 years? So, up to 5 years. So, at the fifth year, it will be 1 plus 0.06 to the fifth power. So, 1.06 to the fifth power times 100,000 is equals to 133,822.56 thousand pesos. Okay, now, as you can see from the initial investment, which is 100,000, umakyat or tumubo ang pera ni Mrs. Ali ng 33,822, which is too much. Walang bangko na ganito. Sa totoong buhay, guys, hindi ganito kataas ang rate, no? It's like 0.05 or 0. Not even that, no? Parang 0.02% siya. So, kung ilipat mo siya sa decimal point, it will be 0.0002, something like that. Sobrang baba, guys. No? But again, this is only for information, for your information only, for you to grasp the concept behind the compounded interest. No? It doesn't mean that we are encouraging you to do this in your real life. Okay, so anyway, 11:10 na guys, no? Nagsobra na naman ako sa hiningi kong oras sa inyo. So I will try to just record a video lesson for the remaining lessons. Actually, madali na lang yung remaining lessons because I have already showed you how to get the domain and range. No? So intercepts na lang at saka asymptote. Actually, na-show ko na rin no, ang kung paano kunin ang asymptote. Guys, siguro i-solve ko na lang din ang intercepts ngayon. No? It's the same as rational function. It's the same as rational function. The solving of the intercepts is the same as the rational functions. If you are solving for x-intercept, no, i-zero mo lang ang y. At kung nag-solve ka ng y-intercept, i-zero mo lang yung x. Yun lang siya para makuha niyo yung intercepts, guys. Okay? And also, if you're going to look at this, no, balik tayo sa graph, x-intercept is nothing. Bakit? Hindi nga siya pwedeng tama sa x-axis. Walang intercept sa x-axis. Kasi nga, the x-axis itself is the horizontal asymptote. So meaning, x-intercept and the zeros are not applicable. Tama man. Now, if you're going to solve for the y-intercept now, paano mag-solve ng y-intercept? Sabi niya, gawin mo lang 0 ang x. So, let's use this example. So, y is equals to 1, 2 to the power of x. So, 2 to the power of x, let's say, 2 to the power of 0. So, ano yan siya? 1, 1, 1. 1 over 1. So, magiging 1 over 1. Where is my, sorry. Okay, so magiging 1 over 1, which is also equal to 1. And let's see kung tama ang ating intercept kasi nag-graph na natin to eh. So, meaning ang ating y-intercept should be 0, 1. Tama man. And that is right. That is correct. Andito siya, nag-graph na natin kanina. Ayan, no? Ayan ang nag-interception niya sa y-axis. Okay, so ganun lang kadali, guys. Kahit hindi ko na i-explain sa inyo ang lesson 4 and 5, you would be able to understand it. I think the only thing that I would be recording a video lesson for is the inequalities. Yun na lang, no? Okay. And solving for, exponential equations and inequalities. Okay, so I think that will be next time, inshallah. So, ganun lang kadali, guys. Ang intercept is solved. And for as long as you know the horizontal asymptote, you will know what is going to be the x-intercept. And remember, x-intercept is just the same as the zeros of the function. So, pag nakuha mo na ang x-intercept, nakuha mo na rin ang zeros. And again, if you are going to solve for the y-intercept, gawin mo lang 0 ang x and solve for it for y as is. So, just like this. Anyway, that's it for today, guys. I think. Any questions so far? May question ba kayo, guys? By the way, for the activities, I will try to record a video lesson as well of solving that. For example, yung mga worded problems dyan, because it might be a bit difficult for you, but it's okay. I will try to record a video lesson for that, okay? And it will be posted on the Moodle account. So for now, walang question, inshallah. So thank you so much for attending the class today and extending a lot of your time for this class. If you have any other questions, you can PM me directly or post something on our group chat. So once again, thank you. Subhanakallahumma wa bihamdik. Ashhadu an la ilaha illa ant. Astaghfiruka wa atubu ilaik. Assalamu alaikum wa rahmatullahi wa barakatuh.